warm evening, everyone. Welcome you all to the 12th edition of Techceleration event by Toyota Connected. Let's talk tech. Thank you for joining us, and we have some amazing talks waiting for you from our very own technologists. Firstly, Sridevi is going to talk about AI using Java. I mean, to be honest, right? I mean, Python and machine learning just coexist like bread and butter these days, right? I don't know if there is a machine learning developer who doesn't know Python, right? Though learning a new language, especially a dynamically typed language like Python is fun, but you can't have a tech that is so much different on a single programming language, right? So, being an experienced Java developer herself, Sridevi has, explored the various tools and libraries that are available to research and build production ready machine learning applications in Java, and she's gonna talk about just that. Secondly, we have Vikram Sweden, who is our senior machine learning engineer. He has done some extensive research on graph intelligence, so you're gonna know about what is graph intelligence, how and why companies are adopting them so fast, both in analytics space as well as in artificial intelligence space, right? um, so we have a QA session planned for planned after each talk, right, to make the talks more effective. So you can either type in your question, before you forget on the chat window, or use the raise hand options on Teams so that presenters can reach out to you. So without further delay, I'll invite Sridevi to go over the topic. Over to you, Sridevi.
Yes, thanks, Ashok. Good evening, everyone, and thanks for joining. Myself, Sridevi. Today, I'm going to talk about AI using Java. AI in Java. Before I go deep into this topic, I want to say, like, why did we choose this topic? So, as Ashok rightly said, whenever we hear the term like AI or machine learning, so the first programming language that comes to everyone's mind is Python. If you want to get trained, if you want to become a machine learning engineer, then the first step that we take is learning Python. So we wanted to learn Python to become a ML engineer, right? So and like when we hear the word like Java as a programming language, so the first thing that we think is okay, Java can be used for web development. Java can be used to create the APIs. Java can be used to create a large scale applications where there will be like different modules and each and every module interact with each other. So those are the things that comes into our mind, but we never think about like how we can do AI in Java. So we never at least most of the people would have never used AI, would have never used Java for AI, right? So we need to break the chain. So the main important thing is I wanted to, like, whatever I know, I wanted to share with you guys, like why we need to go for Java, what are the benefits that are available in Java. So take an example of like large scale application, at least like legacy application. So most of the legacy web applications has been developed in Java. So when we need to do some enhancement, when we need to implement ML in that legacy application. So if we go for Python, so we have to hire another Python developer when we already have the respective libraries, ML libraries that are available in Java, right? So it will break the chain, like the whole application would have been developed in Java. Only for that particular module, we have to go for the Python developer uh, to bring in, and we need to do the integration between the two two modules, right? So when already the libraries are already available in Java, so we can start using like Java existing ML libraries uh, to develop such kind of tasks or such kind of projects, and we can adapt to that, and we can start contributing to like machine learning in Java. So we can create our own algorithms in Java and contribute to the community. And why develop in Java? So why do we need to develop in Java? There should be like some reason, right? So one is like we already have like a lot of libraries in Java. So a lot of open libraries which are required for AI development are already available in Java, and Java is one of the most loved and most used programming language. So there is a big community for Java, and whenever we face some issue or whenever we need some guidance or whenever we want some examples to be seen, so we all those things are already available. And next thing is Java is an object-oriented and procedural programming language, and Java even comes with user interface where which we can use to display the graphs or for any other UI functionalities. So all those things are already there in Java, so we can use all those things. Next thing is what are the benefits of using Java? So one is it is easy to use because it's a large community, right? So it is easy to use, and the code whatever we develop in Java, it is in readable format. Next thing is debugging is so easy in Java because most of the open source tools or IDE, for example, take an example of Eclipse or IntelliJ. So they have inbuilt Java framework where the coding is easy and debugging is easy. And large scale projects are simplified with Java. So as I already said, if you have a legacy application and a complex application, and scaling of that particular project is so easy in Java, and we have better user interaction, time utilizations, and real-time engagement. So all those things can be developed in Java. So these are the main benefits of programming AI in Java. And next thing is what are the popular AI projects that are available in Java? So using Java, we have lot of projects. So some of the popular projects are Robocode. So Robocode is a game that has been developed purely in Java, and the purpose of this game is to teach people how to develop AI in Java. So the goal of it is where we need to develop a game, robotic battle tank game against another which will be battling against another tank that has to be developed in Java. So it is mainly to give the awareness and it's kind of a learning session. So this robocode is a game that can be used to develop this kind of games. Okay, next thing is Java object oriented neural engine. So it is a neural framework, and it is open source, and it is mainly to create, train and test artificial neural network. And Veka is a popular machine learning algorithm, and it is mainly used for data mining tasks. So Veka is the first most of the people who wanted to convert to Java, to build ML applications, the first library that the first project that they go and look at it is Veka. Next thing is what are the Java library that we can use in our projects, like in our ML or AI projects. So we have segregate lot of libraries are available in Java in different platforms. Like for example, for machine learning, we have all these libraries: MOA, Java ML, Rapid MIL, Miner, and DJL. Ego. All these machine learning libraries or come up with vast algorithms which we can use which we can use without any change, or we can train the model for specific to our use, and we can use. Next thing is we even have genetic algorithm libraries. These are the list of library available libraries. There are more to it, but I have just captured the famous libraries here. So all these libraries are mainly used for to create genetic algorithms. Next thing is rule-based system. So Tweety rule, D3 web, Opta planner. So all these things are rule-based systems where they provide all these libraries come up with a simple UI also, where we can give the condition to the algorithm, and we can train the model based on a requirement, and that too without without any code. We can, based on the using the UI itself, we can train our model and come up with a solution. And next thing is automatic programming. So if you see, we have Spring Roo and Aglo, where we can, by using Spring Roo, we can integrate it with any of our IDE, and it will give us the basic code snippet. Like if we want to create any project, so obviously we need the code structure, right? So to create the code structure, we can use Spring Boot. Akilo, it is mainly for Eclipse IDE, whereby integrating Akilo, we can create the basic code structure for our project. For example, like how the package declaration has to be, and what should be the file, the basic files that needs to be there inside the project. So all those automatic programming can be done using these two AI libraries. And we also have neural network libraries which are purely developed in Java. One is like deep learning, Neurop, and Arbiter. And next thing we have NLP libraries, like natural language programming libraries. One is Apache Open NLP and Core NLP. So whatever the libraries that we have seen so far, all these libraries, they act almost similar to how what Python or other programming languages providing. Okay, I can show the demo after this, where like I have like sample code for NLP and other uh, uh, libraries that whatever available in Java. So all these things are think use the similar output, like how we are the how Python is giving, or R or Golang is giving. So we can start using all these libraries to achieve our solution. So the more like the advantage of using Java. So when I say like when I've been talking about Java, right? So the advantage of using all these libraries and which are developed in Java is, first thing is security. We all know like Java gives like a lot of priority to security. So our application, if we are going for a, if we need to build a secured application and ML application, so Java is the first place where we can stop by. And next thing is like Java, as I already told, like Java has a vast libraries in the community, right? So whenever we stuck with some problem, we have lot of what to say, a lot of materials or video that are already available in Java. And Java offers like rich APIs where where we can directly connect to the database, and where we can do the networking much easily. And yeah, this slide is just to give a little hope to Java developers, whoever wants to develop in AI. Just a comparison between Java and Python. So why we can go for Java like rather than Python. So I can say like Python is the first place for AI, but in some of the projects will be like better developed in Java. So I just want to give the comparison between these two. One thing is speed wise, Java is the fastest as it is a compiled language, and Python is slow as it is an interpreted language. And next thing is syntax. Yeah, I should agree. Like Java comes with like more lines of code, and Python less number of code. But for Java developers, it should not matter because we have already been trained with writing like lot of lines of code. And the main advantage is like even though it comes with like more lines of code and the readability. So if I say like readability, like if someone sees like Java code, it is easily understandable. And I'm not saying like it's not Python, but as a Java developer, I can say like it is easily understandable to other programmers as well. uh, like even though there are like lot of lines of code, and yeah, easy to learn. So Java is always easy to learn, and yeah, likewise Python also. Runtime errors. So I don't say no runtime errors, but number of runtime errors are like very less when compared to Python, because we whenever there is an error in the code, during the compile time we will be getting the error, like compiled errors at least. So but Python in this case, no. So Python, in Python we will not be getting any compile time errors, but most of the errors will be seen. That means Python code will run even though there are errors. So if we are, there is a good chance that when we are running the application, there's a good chance to get the runtime errors. Security, as I said, like when compared to Python, Java is more secure. So when we want to develop any application using uh, uh, when any application using like any AI application using Java, we can keep all these things in the mind. and we can start developing the application. So let me just quickly show you guys like about the programs, about the, as I said, like most of the libraries act similar to how the libraries are already in Java, in Python, right? So for example, take natural language processing. So here if you see, like it comes up with like lot of
Sorry,
what is it here.
are you showing something? It's not visible.
Yeah. Oh, it's not visible. Let me share the screen now.
Yeah.
Okay, so if you see, as I told you, like uh, it like we or most of the libraries that are available in Java act similar to Python. It gives a similar output, and whatever the problem that we are facing, so it solves the problems, right? So, for example, take this natural language processing. So where this particular library, okay, this particular library solves like most of the problems. Like it even detects the language based on the string, and it gives us the like tense, like it gives us whether grammar, also whether the particular word is a noun or verb or preposition. So all those things it gives us, and it can separate the sentence. It can separate the sentence into the words based on the token. So all those things, whatever Python is giving, even we can achieve the same thing using Java. So for such kind of projects, like we don't need to go explicitly to Python, so we can use Java. So for example, if you see, I just ran this program. So if you see this, it is like I have a language. Okay, I just gave the language here. Based on this language, it is giving me whether it is Japanese or not. So I'll just run the language detection. So currently it is showing language. If I give like, I have another string. See, like based on the string that whatever we give, it will detect the language, whether it is Italian or Japanese or anything. Okay. So how can we do this? Like, is it we need to write a lot of code? If you see for this particular thing, I just return like 4 lines of code. Yeah, even this can be reduced in Python, but for as a Java developer, like this is good to go, right? So the only one thing that we need to include here is the Maven dependency. We have like Maven dependencies for most of the libraries. So if your project is a Maven project, like you can just add the dependency, and like with few lines of code, you can achieve whatever it is required. And if you want to run pure Java program, like you can download the jars as well. All most of the jars are already available in the market, so you can download it, and uh, you can run the program. So likewise, I have like Eva, it is another library. So if Eva comes up with like lot of simple solutions, okay, like for example, if you want to what to say, if you have like array of elements, and if you want to segregate based on the final count. So all simple things, simple libraries, like simple algorithms Eva comes up with. For example, here I have a list of libraries, okay, a list of values, and in this one I'm giving a target of 100. Okay, so I want to find out like what are the values that I need to consider to reach the target 100. So based on, see, this is a simple algorithm, but yeah, so to reduce a task, so Eva has like this is just one of the problem, but Eva comes up with like lot of such kind of problems and gives us the simple solutions where we no need to iterate over the loop and come up with a solution. So if you see here, yeah, if you see here, it gives us like, if we add like the number at position 31 and number at position 2 and number at position 4, that means that 31 plus 42 plus 27 gives us 100. So this is a simple one, like such kind of like algorithms are already available in Java library, so we can make use of all those things to come up with solutions. So yeah, anything? Are you guys able to see the screen?
Yes,
Okay.
Sridevi.
That's all from my end, guys. Look, any questions?
Yes, there are no questions, Sridevi.
Yeah, thanks, Ashok. Thanks, everyone. So I'll hand over to Vikram.
Hi guys, so give me a moment. Sharing my screen. Is my PPT visible?
Yes, Vikram.
Yeah, thanks, Ashok. Yeah, okay. So, oh my God, so Java is massive, man. So my heart started beating at high speed. So awesome presentation, Sridevi. So well curated details. Thanks for that. Okay, so welcome guys. Welcome to my presentation where I'm going to talk about a bit of graph intelligence. I hope this is going to be, it is going to give some useful information to you guys. So welcome guys. Yeah. So I'll jump into my first slide. So many companies and researchers are reporting Graph AI to be superior AI technique for their use cases. So Graph is more intuitive than a regular rows and column data. So it gives more information. Even if we look at a graph with our naked eyes, right? We can understand a lot of insights from graph. Uh, if we look at a rows and column based database data in RDBMS system, that is not possible. So graph is also useful for not just for making predictions, but also for visualization of the underlying data. So as I said, even if you look at a graph with your naked eyes, you can gain a lot of insights. And companies like Pinterest, Uber, Google have reported significant improvements in their recommendation system, fraud detection, and forecasting model using graph neural network. So let's see some of the use cases in my presentation. So next is, what is a graph to a computer? So graph is a data structure. So it is a collection of vertices and the edges. So vertices are called as nodes. So in my further slides, I'll be referring to nodes instead of vertices, and the edges instead of relationship instead of edges. So graphs are a collection of vertices and edges. So this blue balls are vertex, and the lines connecting them are the edges. So we believe that graph will give us more information than a regular RDBMS based data. So this is a feature graph. So if we look at this graph, we will not gain much information. We just understand that this is a cyclic graph, directed graph, that's all. So this is a feature graph. So this gives us a lot of information. So we would, it is not possible for us to understand this much of information if we look at a rows and column or a table based data. So that is the power of graph. So each ball or the circle is node, and the relationship between the nodes are called as the relationship or the edges. So each of this node will be having a feature vector, and each of the relationship or the edges will have a feature vector. So what is a feature vector? For example, so Melly is transferring a cache to Jean. So the feature of Melly could be like name, address. So this node label should be a person, because she is a person and a person is sending a cache to another person. So this could be a computer as well. So automated payments. In case of an automated payments, there could be a node where the name or the label of the node could be a computer or a machine. So in this example, all the labels, all the nodes are the person labels, and the person label has attributes such as name, address, account number, or whatever it is. So that is a feature vector of the nodes. And when it comes to the feature vector for the relationship, so Melly is transferring a cache to Jane. So what is the feature that this transfer could have? What is the date? What is the amount? Or what is the type? NEFT or some other type of cache transfer. So those could be part of the feature vector in the relationship. So this is a graph, feature graph, where we'll be able to obtain most of the information easily. So the next item is graph analysis. As I told in my first slide, so graph is not just used for making prediction through a neural network. So graph is also used for doing graph analytics or graph visualization. So I've considered two of the techniques. One is graph rank and page rank and page analysis. So page rank is something like the algorithm measures the importance of each node within the graph. Like if you have multiple nodes, if you take a node and find its importance, the importance is like how many number of nodes connecting to this particular node which we are interested of. So the relationship could be in or out of the node. So finding the page rank is something like how many number of relationships that are coming in to the node from other nodes. So that is the underlying concept of page rank. So I believe page rank is developed by co-founder of Google. So in Google, it is used to optimize their search results. So here in Google, right, what they do is they take web page and they are trying it to model as a node, and the hyperlink present within each web page is being directed to another web page. So let's say we have two web page. This web page is connected to this web page through a hyperlink present in this first web page. So this could be modeled as a graph where these two web pages are two nodes with a label web page, and the connection between them is done by a hyperlink present in first web page. So that hyperlink is the relationship or the edge between these two nodes. So this is how it is modeled in Google for optimizing the search results. How many number of hyperlinks coming to this node gives the importance of this node. So that is how they are able to give us most relevant results. Of course, if we search something in Google, we'll have 1,000 results, but the top 10 or top 15 results will be more relevant to us. So that is achieved because of this page rank algorithm. So in finance domain, right, I have got some good diagram to understand the use of page rank. So if you see the left side image, so consider this as a transaction representing transaction between multiple people. So if you see the left side image here, sorry, so a person is sending money to multiple people, and all of them are sending back the amount to one person. So if you see this, it looks something fishy, right? Some fraud is happening, or some money laundering, or something is happening, right? So this is easily understandable if we look at the graph. So graph visualization is not directly, easily given to us. We have to write some Cipher query or some do pre-processing on the underlying data, so that we'll get this kind of visualization from the graph, from the underlying data. So by seeing them, we can easily understand there is something fishy happening on the left side, and on the right side, if you see multiple people are sending money to multiple people's account, there is no traces for something fishy that is happening. So this is the power of graph to understand how the transactions are happening. So by this, we will be able to do fraud detection in payment domain, or even we'll be able to do recommendation for recommending. If this is a social network graph, then we will be able to recommend users. So we keep getting right the people you may know in a social network page. So that kind of users can be used using this page rank algorithm. And the next one is path analysis. So path analysis is like, is there a path between two nodes? So how many hops are there in the shortest path? We all would have read Digista algorithm, right, in our DSC papers in our college days. So that is used here. Digista algorithm is nothing but finding shortest path between between two given nodes. So there could be many equal number of shortest path, but Digista algorithm will try to give us a well optimized path between two people. So if you see in this diagram, so this diagram tells that this is the optimized or shortest path between these two people. So again, this could be used in recommendation engine, like recommending people you may know on our social network page, or this could be used to find the shortest path between two places that will be used by food delivery companies, or this could be used in maps as well. So the next is short introduction about graph database. I'm not going to talk much about graph database in this presentation. So I'm just going to give a gist or a flavor of graph database. Graph database, in graph database, the data is stored in the form of graph only. It is not like it is stored in a different form or rows and column form in the underlying tables, but it is when it is queried, it is showing us to this format. It is not like that. The graph is stored as graph only in the graph database. That's why they are called as graph database. So the data is stored just like you might sketch the ideas on the whiteboard. So as I said, it is just stored as a graph only. So some of the examples for graph database are Neo4j, Amazon Neptune, Azure, Cosmos DB, Oracle Spatial and Graph. But why I'm not going to talk much about graph database in this presentation is, for doing any analysis or making any predictions, right? We don't have to have the data in the graph form itself. So most of the companies will be having the data in form of rows and columns, that is in RDBMS system, or they might be having the data in form of a document database. So they don't have to invest heavily to convert all the data into a graph database and then make it into action for making any prediction or whatever we want to do with a graph. Instead, we can use the data present in the underlying system itself in any form, and we can, whenever it is required, we can convert those rows and column data into a graph format on the fly using Python packages. So that's why for making any prediction, we don't have to have graph as a database. So that's why I'm not going to emphasize more on GraphDB in this session. So this slide consists of some basic syntax that we can write using a Cipher Query. So Cipher Query is nothing but similar to SQL but optimized for graph. So this is a query language we use to extract information from database like Neo4j. So assume that there is a graph already stored in Neo4j, and it is a graph between product, customer, and order information of some e-commerce website. So the first query is like match product and return P. So this is very similar to select star from a table called as product. And the second one is match product, where product name is chocolate and return 2 of the column. So this is very similar to select product name, unique price from the table product, where product name is chocolate. So that is how it is. And the third one is equivalent to a join query in the SQL that we use. So here what we do is we already filter for product name is chocolate. There are two types to filter in graph database. So one is directly specifying it in where, or we can specify it in along with the node name itself. So I should have told this before. So this product or order, customer, these are all not table names. These are all the node names. So if you see in this diagram, so consider these 3 labels as I said, they are all the labels for person. So similarly, we will have in my Cipher query, we will have nodes like orders, customers, or whatever it is. So they are not tables as such, they are called as nodes. We will have many number of, if we consider RDBMS, there will be only one table in the name called as product or order or customer. But here we will have a lot of nodes with the label name equal to product or order or customer, but they will have different attributes or different feature vector. So that is what I wanted to emphasize in this third query. So this is very similar to a join query, but in this, if you see, we have not used the join condition. The reason is because graphs are already connected. It is all already related. If there is a product and the customer has bought that product, there will be edge representing that the customer has bought that. So in the relationship, will have the status equal to purchased, or if we have just liked it or added it to the wish list or added to the cart, the relationship will have status equal to added to cart or added to wish list. So this is the reason we don't have to explicitly give a joint condition between different nodes, because it is already connected. So yeah, so that's about the Cipher query. So I'll go to the next topic. Meanwhile, I'll have a time check. Okay. So next topic is graph neural network. So I believe this is the topic where most of us would be interested in. So graph neural networks are another neural networks that we usually use for any NLP or CV or any regression or classification problem. So to give a primer about neural network for those who are not already aware of neural networks, the neural networks are like we give input to a neural network and lot of non-linear transformations occur in the black box, and finally we get probabilities as an output in the final stage. With these probability we are trying to infer. Let's say if you are trying to pick a class or find what is the category that the input belongs to, we'll pick which index has maximum probability. So this is basically neural network. Inside the black box, we'll have a lot of neurons in each layers. So transformation, the nonlinear transformation and the activations will occur layer by layer in a sequence. So we can have any number of layers as we want according to the problem and the given use case and the given data. So we as I said, we have input and a black box that has, sorry guys, so that has lot of layers with neurons, and finally the probabilities given as an output, and we choose one of the classes. So this is a neural network. Similarly, graph neural network are also a class of deep learning method designed to perform inference on the data described by graph. So in the regular neural network, the graph, the input data could be just a vector or a matrix. Similarly, in graph neural network, the actual data is a graph, but we don't actually feed the graph directly inside the neural network, because as we all know that in any CV or NLP based problem, right, we have words. Let's say, let's consider NLP problem to make classification of a sentence. So let's say that the Techceleration event organized by us is good. So if this is the input word, that input sentence comes to the neural network will not understand these words as such. So each of this word should have a embedding representation. So this embedding representation will be of any size. If you take a bird model, the size of a vector for each word is around, I believe it is 768. So each word will have 768 number of numbers to represent. So similarly, graph cannot be directly fed into the neural network, as how we are converting each word that we have before feeding it to neural network using a technique called as embedding. Similarly, we create embedding for each node. The neural network will not be able to directly understand. We have to first convert them into embedding and then give it to neural network, and then neural network will do all the magic we require. So be it classification or regression or something, or sentiment analysis, whatever it is, or predicting top 10 recommendation for something. So all the magic will be done in the way how we design the neural network and how we handle the final output path. If you want to classify, we directly go by the probabilities, pick the probability that has maximum value, and if you want to do a recommendation, pick top 5 probabilities or top 10 probability. So all the magic is done by neural network and the way we use the output of the neural network. So similarly, as I said, we are going to use the embeddings of the nodes. So these are some of the techniques that I'm talking in the slide. So one is deep walk and graph stage. So deep walk is nothing but the algorithm will randomly choose one node and it will randomly traverse through all the nodes to reach another node. So it all happens randomly, right? So by randomly traversing through all the nodes, the algorithm tries to first understand or prepare an embedding for each node. So what are the information we have for preparing the embedding? So let me go to my first slide. Yeah, so if you see in this node, so each of this node is representing a person. So label is person, and each of the node has attributes like name, address, account number. Sorry guys, and the connection between them are also having the attributes called as date, amount, the type of transaction, all those things. So these are all the information that we have when we randomly walk through a graph. So if you want to find embedding for this person Gene, so we see that Melly is connected and John is connected to this person, and we have two relationship between them. One that is cash transfer again. So each of the node and the relationship have some feature vector associated with them, and this is all aggregated and then converted as an embedding for Gene. Similarly for John is connected to Melly, so we'll develop an embedding for John node as well. So this is how the embedding is learned. So this is very similar to, if you guys are aware about CBOW technique, continuous bag of words, or skipgram techniques. So we just give corpus of words to the algorithm, this algorithm, and it tries to mask a word and try to predict it. By doing that, it is able to understand embedding for each given word, and afterwards the embedding will be used for some purpose as we discussed. Similarly, in Deepwalk, it tries to traverse through one node to another node, and it takes the message from each node to the next level. So it is called as message passing in this GNN world, and it tries to aggregate all the information and find what is the embedding for the final node. So that is Deepwalk. But the disadvantage with the Deepwalk is that, right, if there is a new node attached to the given graph, then it has to traverse all again from all over first, and then it has to learn the embedding. But that is a tedious task, right? So for that purpose, graph stage was introduced. It is a research paper. So it tries to learn embeddings on an inductive way. So even if a new node attached, it can understand, I mean, it can come up with the embedding of the new node by the nodes connected to it and the relationship it has with the other nodes. So we don't have to learn all over again. So that is the advantage of graph stage. And also, if the underlying data is very huge, that our neural network or our Deepwalk is not able to grasp it at a stage because of the given memory or CPU constraint, then graph stage is there for rescuing us. So graph stage can process subgraph by subgraph to understand this embedding of each node. So this is all about the techniques to understand embeddings. So let me directly jump into some of the node classification applications of graph neural network. So I have node classification, use case, and then link prediction, and then finally knowledge graph. Okay. So let's have a time check. Okay, the first use case that I have is battery life. So before going that, let me reuse this formula in the top. So this is the formula for finding the embedding. So this was there in one of the paper. So as I said, we have information of the nodes connected to the node that we are interested, and the relationship that the node has with other neighbor nodes. So that this is the information we have. So in this formula, if you see, we are trying to find the embedding for a node called as V, and XV is the feature vector of the node. Feature vector are like in my first slide, if you see, the person node has vectors like name, ID, or account number, whatever it is. It will be kind of a JSON or key value pair. So XV represents them, and XCOV represents the embedding, I mean the feature of the relationship. So as we saw, right, cash transfer is a relationship, and the feature for cash transfer could be the time or the amount or the transaction type, whatever could be. So that feature vector is represented by XCOV, and HNE are the embeddings that was already learned for the nodes connected to the given node V, and XNE is the feature vector for the neighbor nodes. So HNE is the embedding of the node, and XNE is the feature vector of the neighbor nodes. So these are the information we have to find embedding for a given node. So let's say we have already found embedding for all the nodes for finding the battery life. That is a basic first assumption that I have. So for modeling a battery life, right, in automobiles, it is very crucial to model battery life so that it avoids a lot of cost or battery failures or whatever it is. So it is kind of a preventive maintenance that we have to take to preserve, to save our car battery. its life. So that's why the battery life modeling is very useful in any automobile industry. So the way I'm perceiving modeling the battery life is like a lot of electrical and electronic components will be connected to battery. So each of them are going to consume some energy from battery, and the battery life is going to get decreased. Of course, the battery will be charged as the car moves, but there is a life associated with the battery, right? After a certain point, I believe it cannot be recharged or something like that. So it is important to understand the remaining useful life of a battery, as I told. So I perceive this battery life problem as a graph because all the components are connected to one battery. So this looks like a graph, right? Rather than representing it in rows and columns. So if you model them as a graph, it's more intuitive to understand. And as we understand more, neural network can also understand more on the graph. So that is the power of graph neural network. Humans can also understand, the model also can understand more on the given underlying graph data. So what I'm going to consider is, I don't have any demo prepared for this, but I have some beautiful diagrams that I draw on my own, so bear with that. So considering the data to be a time series data representing the remaining useful life of battery, and model all the electronic components that consume battery as nodes. So the node of all of these components will have the label called as components, and then it is all going to get connected to one battery, or probably if you have two batteries in a car, it will be connected to two batteries. So whatever it is, so we have nodes with the labels such as components and battery in this in our problem. So the edges representing, or the line connecting two nodes, will be the consumption rate. Component 1 is consuming battery at this rate. So that is the feature represented by the relationship. So we will see this. So on the left hand side, I have drawn some components, and the components have some feature vector like name, power, consumption. And all of them has same same feature vector, but this can vary. So each component may have different key value pairs. It is not a problem. And the relationship between each component and battery's consumption. So this consumption is also having a feature vector key value pair, and the energy dissipated due to the consumption is timed at time t1, t2, t3, and the battery's useful life is also timed as a time series data where the key value pairs are like t1, t2, t3. So t1, t2, t3 are the actual values that if you want to predict. So this represents the actual remaining useful life, right? So this is how. So if we feed this model for any algorithm to learn the embedding, and then if you give this to a neural network, it will alert the user of a car in advance to, alert the user in advance to say that, hey, so this is the remaining useful life of battery that I've understood from the data I've trained with. So please take a look at it. So this is what this algorithm is going to alert the user. And the another way is to model a graph in a kind of a classification problem. So this will be kind of a linear regression problem where we're trying to predict what is the RUL value that could be on a given instance of time. But in my next slide, so this I've modeled little differently so that it can be viewed as a classification problem. So the left hand side components are going to be same, but in the right hand side, battery is modeled into 3 copies. So first copy is having 0 to 30%, the next one has 30 to 60%, and the next one has 60 to 100%. So these are all the 3% that I want to classify. If you want, you can have 10% as an interval, or 5% as an interval, or probably a bigger interval when we traverse from 100 to 80 to 60, and small intervals when we approach around 20%, because we will be interested to know when the RUL is going to end. So that is where we are interested in. So we want to have more precision in the output, then model in this way that I'm recommending. So here for demo purpose, I just have 3 number of classes to model the battery's life, RUL, based on the RUL. So battery is connected to other components. Again, the relationship is going to be consumption. Probably if the energy dissipated metric is not good, we can add any number of metrics or any metric we want to represent the relationship. So with this modeling, graph modeling, this whole problem can be perceived as a classification problem, where we have to first learn the embedding of all the nodes and then give it to a neural network, and then the neural network will try to classify any instance of time under one of the category of battery, so that user will be notified that hey, you are in this category, in this range, so see if you have to do something on your battery. So that is what this algorithm is going to represent. So this so this comes at a node classification. So I should have already told this. So graph can be in graph neural network, we can classify a node or classify an entire graph or classify the relationship. So in this case, we are trying to classify a node to understand what is the remaining useful battery life. So in my next use case, I am going to talk about is classifying the relationship, that is called as link prediction. We have two nodes, and the nodes are assumed to be linked to each other by single direction or by bidirection. So here in this, we are trying to find what is the relationship between these two nodes. Probably we are trying, we have a feature vector. We will have feature vector in a similar set of nodes, but in this node, let's say we don't know what is the feature vector for the relationship. So we may try to predict what is the feature. Let's say this is the product and this is a person, and we can say that the relationship is positive or negative. The person likes this product or not. So this can be predicted. So this kind of application is called as link prediction application in graph neural network. So this is kind of a recommendation algorithm. So I believe all of you are aware of the recommendation algorithm. So we all will be using e-commerce platform, right? So we'll have the recommendations, like we will be having, like, so people also have bought this product, or people also likes this, why don't you try this? So this kind of recommendation will be given. Also in our social networking page, we'll have recommendations like people you may know, even though we know or we don't know. So we have those kind of recommendations. So that is the recommendation problem. So basically in recommendation problem, we can approach any recommendation problem using a collaborative filtering technique, or user product or product interaction technique. So similar technique we can use in graph neural network as well, but the change is the underlying data is not rows and column or a vector. The underlying data is going to be the graph. So in car, right, automobile industry, right, the drivers listen to music while they drive. So what we are trying to do is use cases, we are trying to recommend the proper music or playlist to the user, so that he don't have to manually find or tune his radio or tune his playlist to select a song while driving. So it is not good, right? We should be concentrating only on the road while driving. We should not be concentrating on other stuff. So we'll do other stuff. So that is where our area of expertise is. So we can collate the songs while the people listen in their car, and also we can collate the ratings that the people has given to each of the song through some account, or if the car company is itself giving some account for managing the playlist, so we can collect the rating information from that account. So this data can be used to construct a matrix. Basically in regular recommendation algorithm, we'll be constructing a matrix where our rows will be the product or music, and our columns will be the users, and we write some sparse vector to represent whether the user likes or dislikes, or will have a proper vector to represent what is the rating given to each song by the user. So this is the basic information that we have to start with the recommendation. But here we have the graph as information. So graph is much more intuitive than, as I said, than rows and column representation in some areas. Of course, in some areas, rows and column representation could be better than the graph representation. But for recommendation, we believe that graph representation are far better than rows and column representation. So first we try to learn the embeddings for each of the node. So what information we have? We have the ratings given by the user, and we have information like whether the user likes or not, or whether the user listens to these kind of songs or not. Apart from that, what information we have? We have information about the song, who is the author, or probably who is the singer, or what kind of song it is. So these are all the informations we have to build our graph. So let's straight away, before seeing this diagram, so let's see what let's understand that I have constructed a bipartite graph. So what is a bipartite graph is? The bipartite graph is a graph that where the group of nodes present in one group will not be linked to each other at all. Instead, it will be linked to only the another set of nodes. So in music recommendation, we have two type of labels. One is users and one is the music. So we will not be having mostly the relationship between each user, because users will be the users of the car itself. So we will not have any relationship between the user of one car and user of another car. Probably we can have relationship between users of same car, probably father, wife, son. So we can have some relationship between them. But for this discussion, I'm just assuming that there is no relationship between the users. All the users are just connected with some music labels. So that is a bipartite graph. So this is a representation of a bipartite graph where left side has person and right side have nodes with the label songs. And we see that person has some feature vector and songs has some feature vector and the relationship has some feature vector. So relationship is like dislike or rating or whatever we want to have as a key value pair to represent the relationship better. We can model them in this graph. So again, as we discussed, we are just going to find the embedding of the nodes and then we are trying to predict whether a new relationship can be built from the given data. Let's say there is a song coming added to this list and there is no relationship from person 1 to the song. Probably we may have a relationship between person 2 to the song. So now in this use case, we are trying to predict the feature vector of the relationship, whether if the feature vector is predicted to be rating greater than 3 or the reaction to the user, reaction to the song is like or dislike. Based on that, we can recommend the song to the user. If the outcome of the model is rating 4 and the reaction is likes, then we can develop a connection between the person 1 and the new song. And what it means, representing a relationship between the person 1 and new song, which means recommendation of that song to the person. So many companies believe that, and many researchers believe that the graph neural networks that learns from a graph as an underlying data can better understand these relationships. Because right, if let's say you all would have heard about LSTM, long short memory, right? So in that, even for LSTM, there is a memory constraint to just remember only few number of sequence. It cannot remember whole lot of sequence. It has some memory limitation. Let's say person 1 likes song 1 and person 2 likes song 3, and there is a new song called a song 4 that is not present within the range of person 1, but the song 4 is liked by several other person but the common relationship is the music of the music that person 3, 4 or 5 sorry guys, I'll put it like this. So the music listened by person 4, 5 or 6 has listened the newest song, song 10. Then it means that there is many number of hops that we have to make from person 1 to come to the song 10. Probably to person 1 to song 1 and person 2, then song 3, something like that. The LSTM or RN based neural network cannot remember these many number of hops to reach from person 1 to song 10 for making prediction. But this neural network, the representation of the data is very easier, and the embeddings are easily learned, and the embeddings are much more intuitive. So with few number of hops, this graph neural network can predict that the person 1 may like the song 10 that is added to the system. So otherwise, this will be difficult. Will we process the same data with probably some other neural network? Yeah. So that is the advantage of graph neural network. I'm not sure if the comparison with graph neural network with RNN based architecture is correct for recommendation algorithm. So yeah. So next one is knowledge graph. So knowledge graph we have. So Google knowledge graph is of course obviously discovered by Google. So in Google Knowledge Graph, right? Have you ever thought what is the magic that happens when we search something in Google.com and when we see more relevant response than we want or than we thought of? So let's say if you are searching for resort stays, the search engine will suggest us some tourist place as well. So let's say we are just searching for resort stays, but the search engines can also recommend us some tourist place. But what is the magic? That resort is not synonym of tourist, or so tourism is not synonym of resort. So it is not just a web scraping based technique, but the graph does the magic. So probably in other cases, right? If we are searching for a keyword, the search engine might find the synonyms and see if those similar synonyms is present in other web page or not. So that is just a web scraping kind of technique. But in knowledge graph, right, all the vertices are connected through relationship. So the knowledge graph will easily understand that the resort is connected to tourism places in some way, with few number of hops. So resort should be a node, tourism place should be a node. So the graph will easily find a relationship between resort and the tourism places. So that is how when we search for resort stays, we also get to see tourism places. I'm not sure if so we'll get if you search in Google now and we'll be getting this tourism response. But so this is how the knowledge graph works. So when we search for resort, it should also bring us the tourism based responses. So that is the magic done by knowledge graph. I mean the graph present in the underlying system. So in automotive sector, right? As you all know, we in Toyota Connected try to bring great features that help the users of the car. So as we develop more features that will be useful for the users, we have to educate the users about the feature, right? So if we take any system, there should be some manual. So even in automotive sector, as Toyota Connected develops a lot of useful and exciting features that can be of great value to users, the users has to first of all know how to use them and what the feature is about, right? So that is where we can build a system. We can exploit that situation and build a system called as QRG or FAQ, frequently asked system. So where we can have an underlying manual as a data and build. You all know we have manual for all the products that we have in this world. So we can have manual as a data and we can build graph on top of the manual, and we can have it as a knowledge graph to serve and give different or relevant response to the questions that the user may ask. Let's say you have you guys have give me a moment. Yeah, so we have a manual here and we have a graph on top of that, and let's say we have a chatbot on top of that, or some virtual assistant on top of that. Let's say the car user is going to ask some question to this virtual assistant through typing or through voice, whatever it is. So then the virtual assistant should go and check the knowledge graph and understand what relevant information it can pick for the user from the knowledge graph built on top of the user manual, so that this chatbot can effectively give all the relevant information about a feature, or if there is another feature added in the car, then it has to give the information of that feature as well, even though it is not asked, because there is a relationship between the feature that the user asked initially to the new feature that we also give it as an added response in the give it as an added response by the chatbot. So so this is kind of a FAQ or something, some system. So I have not drawn an image for representing them, but this is knowledge graph, where this is a knowledge graph application which we can use in our automotive sector to educate the user about the new features. So this is a representation of a plain graph and knowledge graph. So in knowledge graph we will disintegrate nodes at a greater scale, and we'll have a lot of features and lot of relationship between the nodes, and even the relationship will have more number of feature vector associated to them. So if we search for something, we our chatbot will know that there is much more relationship with other nodes for the actual node that we are searching for. So let's say it retrieves the information with that it has retrieved by making 2 hops from the given node, or probably 3 hops from the given node. So all of this information can be collected, and it is believed that these are all the more relevant response that a chatbot or the search engine can give, and it is given to the user. So that is how the knowledge graph is used. That it is one of the way that we can use it in an automotive sector. Yeah. So that is all about my presentation. If there is any question, you guys can ask me. Thanks for being patient and listening to the presentation. Any questions, guys?
We have a question from Sukesh. You could look at the chat.
Yeah. Okay. How many layers? So right now I'm researching on that. So it all hyperparametric tuning, right? It all purely based on the data that we have. So I'm just researching on that. So probably if you want to have more information on that, you can connect to me through my LinkedIn profile. So once I complete my research, I'll be able to provide more information on that. But basically, it depends on the data that we have. That depends. So we have to, like how we do web scraping, right? The question is like, so what is the method that we use to construct knowledge graph from the manual? So it is very similar to doing web scraping and then converting it to a knowledge graph. There are tools available. After we do web scraping of the content, we can convert them into graph on the fly. So we have a lot of Python packages. I have not included them as I do not feel that it can be part of the presentation. So yeah, so we have some techniques using libraries in Python. Your voice is
am I audible?
Yeah, you're audible.
Yeah, Vikram. So Sukeshan here. So regarding that knowledge graph question, the Python packages you said, right? So are they based on machine learning? Like, can they identify the entities and their relations from the manual? Because according to my knowledge, like the knowledge graphs are built using entities and relations, I guess. So I'm not.
Yeah. So it has to first identify the entities and extract them, and then based on that, it has to build the knowledge graph. That is how it works. Yeah. So if the underlying data is rows and column, it is much more easier to find which to predict which can go as a node, which can go as a relationship. But for building knowledge graph from a corpus of words, yeah. So entity recognition has to be done, and so there is another term that we use while building dialog flow. So those things can be used. Those things has to be used for building knowledge graph from corpus of words.
Oh, thank you. Thank you.
Sorry, I was on mute. If there is no other question, I would like to give it to Ashok Ramdas for closure and notes. If there is any other
Thanks.
question,
Yeah, thanks to Sridevi and Vikram for the detailed walkthrough, especially with the examples that Sridevi provided and some of the use cases that Vikram touched upon. I hope they would have helped the audience connect to the topic in a better way. So I'm sure the audience will be like taking home quite a lot of things. So thanks again for all of you attending the Techceleration event. And if you want to like revisit the talk, or any of your friends could not make it, you think this will help them, you can share the recorded version of this talk, which will soon be available in our Techceleration's YouTube channel. As any event, right? We look forward to getting your feedback so that we can see how we can improve the event. So if you find some time, please do share your feedback. And if you'd like to participate in our upcoming Techceleration events, please let us know. Until then, see you guys next time. And you all have a wonderful evening. Thank you, guys.